Hello, good morning. This video is about demonstrating how you can split up a monolithic application into smaller microservices so they all fall under the 12 factor application principles. The advantages of trying to break an application into microservices are, as per the 12 factor principles, you can all have individual components, so each and every application component knows only one thing and it does that thing very well. So it is much easier to scale those apps because now you don't have to worry about one single application getting scaled, but you can individually scale the separate components of an application, as we can see in the demonstration. So for example, let's say you have an application that has a web component and a database component, and you find that you have to scale the database application. It's much easier because the database is now a component that can be scaled individually and separately from the whole application, and the layers between the application remain the same, so you don't have to re-architect the application every time you have a scalability needs. So the example that we're going to do uses a tool called Docker Compose. Docker, as you might know, is an environment to allow you to manage containers. So you can have a node which is a box which can have a lot of containers, and they can all work as if they are like individual virtual machines. So you can have multiple containers in a single box, and Docker Compose allows you to compose a lot of containers into behaving as if it's a single monolithic application. So the agenda that we're going to have is we're going to talk about the problem statement and what challenges are currently facing. We're going to take a demonstration app, which is quite a complex application, and show the standard architecture diagram that we have for it, which will tell you all the individual pieces that are there, and then we'll talk about the solution overview, like how we are going to solve the problem of breaking this monolithic app into multiple individual components, and then we'll finally wrap up with the demo that shows up the monolithic app as well as the broken apps, and also show ways by which you can see how these things interact with each other. So what's the problem statement and what are the challenges that we have right now? We have like monolithic applications, which are apps that have multiple components inside them. There's typically, so if you take a standard SaaS web application, you have a web component, you have a database component, you might have like RabbitMQ nodes to actually transfer the load between the main application to like backend workers. You might have separate file servers that are there for like storing images and users files, and you might have other things like CouchDB or stuff like that that will allow you to like offload some of the mobile functionality into CouchDB and do like complete offline apps. But each and every application is different, so you might have a lot of components that are there that make up your single application. Because of all these components, they are huge, and it looks like the application is very difficult to manage because of the size of the application. And the server cost also goes up high if you have to buy like higher capacity hardware. When you start like buying bigger and bigger hardware, at a point it breaks, and then the prices become exorbitantly high, and it's much easier to have smaller boxes that are many of them, and then you can like make them a cluster and make your services run on those individual clusters. The standard problem that we have if you have multiple boxes is the operational cost goes high, because you have each and every one of these boxes and you still have to pay the operations people to be able to have boxes, like have more electricity, more ACs, and like this thing, everything that goes with having a box and managing them. It also becomes very difficult to scale because when you scale an application horizontally, there is only so much you can grow, because the boxes can only come up with so much of a capacity, and if you want to have to scale the app, it becomes very hard. And also becomes harder if you wanted to scale certain portions of the app, because let's say I have a web app that gets a sudden spike and I want to increase the number of Apache servers. It becomes very hard because I have certain problems with it, like how many port 80s am I going to run. So how do I create a load balancer that's going to manage all of them? What other components of my app have to change according to that? And it's also difficult to have a horizon to actually have a single app be able to compose into multiple portions. So I'm going to take an example of a demonstration. For the purpose of demonstration, I'm actually going to show an app which is currently live, and it's got, this is how it works. So you have you actually have a user who goes against a load balancer. The load balancer basically breaks into a couple of web nodes. So there is a couple of web nodes. Each of them has a varnish, and it's got an Apache backed by Symfony apps that are running on that have Symfony apps that run on Apache and connected through PHP FPM. We have a huge MySQL cluster, so you have a master and a slave, and you might have multiple slaves depending on how the loads are. You have a bunch of Solr nodes which are used for searching. So for any kind of searching in the application, we kind of use Solr for it. We have a file server which also acts as the storage for all of the files the customers use. It also stores some kind of utility scripts. We have a RabbitMQ node for like trying to transfer information between the front end and back end workers. On the mobile side, you have CouchDB, which is like a NoSQL database that's available. So as you can see, this thing has lots of components in it. So we have a load balancer, we have a couple of Apache servers, we have database servers, we have a file server, we have a RabbitMQ, we have Solr, we have CouchDB. So about 8 or 9 services, and if you put all of them in a single box, the problem is if I have to scale, let's say I want to change the number of Solr nodes from 3 to 4, kind of becomes very hard because I only have so much memory that's available, so much cores that are available in a box, and I can't exceed beyond that. So how are we going to solve this problem? So as we said before, we're going to use a tool called Docker Compose, which basically relies on Docker for containerizing your applications and composing them to behave as if it's a single app. So each and every part of the application, as you saw before, so the web parts of it become a container, the MySQL portions of it become a container, the RabbitMQ becomes a container, the Solr nodes, each of them becomes a container, and you're basically composing them to become a single application. So you're breaking the application components into individual containers. The problem that also comes up is how do you manage the data that's shared between all of these things? So if I have a web component and a file server that shares data between them, on a single box it's kind of easy because they all live in the single box and they can associate the file volumes easily. But we're going to extend the same concept to Docker Compose. So we are going to share the data into something called volumes, which will typically have to live somewhere else because you don't want to lose the data in case the box goes down. And you'll mount those volumes onto the individual containers, and it gives the perception that everything is living on a single box. And the advantage of having every one of these things run as a separate container is it has only one responsibility. Everything is supposed to be doing only one thing. So it's not like the box is like managing Apache, Nginx, PHP, MySQL, CouchDB, supervisor scripts, all of those things. But every container just does one thing. So one container is only responsible for running Nginx. One container is only responsible for running Apache. One of them is running MySQL. So it's much easier because you can separate the responsibilities. And if one of the nodes goes down, it's much easier to replace that node rather than try to replace a whole box. So those are some of the advantages that we have with this kind of an approach. And we will store the changeable data as volumes. So if you have, like, for development purposes, let's say that you're trying to develop this thing, you can have the local source code locally and you can mount them onto the individual containers. So it gives the perception that they're all living on the same box and you can do the whole thing. So this is a snippet of a Docker Compose script, but I can show you some parts of it as we move on. Let's without any further ado, let's just get on to a demo so I can show you what is the original app and how are we going to see it as a Docker Compose application. So this is the app that we are looking at. So this is running as a single node. So it's got a single server that contains all of those pieces that we talked about here. So this is a single server that's living on Linode that contains all of these things. So you don't see the various components, but everything is living on this single one. So for example, I can look at customers, I can have diaries that are there, like who uses what and various things like that, like what are all the events that somebody has got and then what somebody is doing. And this is all application specific behavior, but then this is all living on a single box. If I have to go back to this slide, you can see that there are so many parts of these applications that we now have to break it into individual pieces so they can be composed and make it behave as if it's a single app. That's where Docker Compose comes in. So if you wanted to see how the compose file is, you could actually see that this is my compose file and I'm using Docker Compose version 2, and it tells you that these are all the services that I have. So so if you actually look at it, it actually gives you all of the just a second. So can just run the services. So you can actually see that my whole application is now composed of all of these services. So I have Zookeeper, which is basically a configuration management tool. I've got Gearman for like managing my workers. I've got Solar for searching. I've got CouchDB for like offline applications. I've got RabbitMQ. This is my core application, which is mounting the source code. I have Apache. I have the data component, which manages the data for the whole application. I have a PHP layer. I have a database layer. I have a couple of supervisor layers. So I've basically broken this whole diagram into 10 different parts of it. So you can actually see that the whole application is now broken into every one of these pieces. And one of the advantages is like the speed of startup of all these things, because everything is now a container and you've already pulled in all those containers. Trying to start up the application is as simple as that. So when I wanted to just start up this whole thing, I will just do an up and put it onto a daemon mode, and it basically starts up my whole application. So right now I have every one of these pieces. So I had Zookeeper, Gearman, Solar, CouchDB, all of those things have all been started. And if I wanted to look at the status of all of those things, you can see that every one of them is up. The data component is not really a container, it's just a volume for storing, that's why it's actually exited, but everything else is up. So every one of my components is actually up. And if I wanted to view the application, you would see absolutely no difference between how you see it on a normal system like a single app versus how you see it here. So just log in. Okay, so I've basically logged into the app and it actually looks like there is absolutely no difference from how it was before. So you can see that you have like basically customers and you're able to see the diaries and whatever. So if I wanted to create a test event, so on and so forth, what I wanted to say was that the application is no different than anything else, and behind the scenes it's a completely functional app like the other one that we saw, even though every one of them is a single container right now. If you wanted to see what are all the pieces that make up this container, you can we use something called as a Weavescope, and Weavescope gives you what are all the parts of the app that are in there. So if you wanted to just give me a second. Okay, so those are all the containers that we had. It takes a little bit of time to initialize and it'll tell you what it is. So but this is a visualization of how the whole application is composed. So as you can see, there is an Apache node, there's a PHP node, there are different application containers, there's a database container that's linked to supervisor, there's a Gearman, there's a RabbitMQ component, while the loop is, but each and every one of them is actually different. So if you wanted to see, for example, what's inside this, I can click on it and it'll tell me what the CPU is, what's the memory component is, what are all the services that are actually running. So I can see a lot of PHP FPM processes because I have individual threads that are actually running. And if I wanted to actually get into the node, I can actually get into the node and it gives me a view of how my application is composed. So get into Bash, and I can see my application source code, and this is where my logs are. So if I wanted to look at my logs, you could see that I did access everything that we do. For example, so if I just as an example, just to prove that this is a live application, if I go back to this one and kind of like do another page or something here, I should see the logs come back here and add those things. So I went to the customers page, so it showed up. So this is the real app that we are actually showing in here, and you'd be able to see those individual pieces as well. So if I wanted to see what is the load on, I don't know, Solar, for example, you would be able to see that that's the load and what are the processes that are running. So this gives you a visual scope of what are the things that are running, and the advantage that we have here is everything is now an individual service. The advantage that we also have is if I wanted to scale one of those nodes, all that I need to do is do a scale, and so if I do a scale and say that I want to scale one of my servers, so let's say I have a component, so these are all my components, and let's say I want to scale Solar, it's as simple as doing scale solar equal to, so right now I have one solar node. If I wanted to make 3 solar nodes, that's all I have to do. So when I do that, it actually scales my application into having 3 nodes instead of having 1 node. So if you can look at the status of this, you can see that every one of them is just like one app. But when I run the scale command, it basically makes it run multiple applications of it. And the beauty of it is, because we are trying to access the apps through something called as a service layer, nothing changes in your application when you actually extend the number of containers. So when I want to say make the number of containers from 1 to 3, there is no change to the application, because we are accessing the 2 parts of the application through something called as a service name, and the service name remains the same. So for example, let's say that my name of the service is solar service. Solar service points to one solar node or many solar node, depending on how much I want to scale the app. So there is absolutely no change to the application, provided it's configured initially properly. Instead of pointing to the individual node, if I point it to the service that corresponds to the node, it doesn't have any change when I try to scale up the app or scale down the app. So those are some of the advantages that we have with the Docker Compose based solutions. And as you can see like how simple it is to bring down an app. So if I wanted to bring down the app and I wanted to like stop it because I'm done for the day, all I have to do is that. And when I do Docker Compose down, it basically stops all those containers. It's as fast as doing an Apache stop, for example. So it actually stops it, and it is trying to clean up some of those containers, which is why it's taking a little bit of time. And if I wanted to bring it back up, it's just that. So when you do a Docker Compose up, it just basically brings. I did a down instead of a stop, which will actually remove the nodes. But if I wanted to just bring it down, I could have just done a stop instead of a remove, which will basically just stop the node and not remove the node. So those are the advantages that we have when we try to break a bigger app into some of the smaller components, so that it's much easier to manage them easily. So if you wanted to look at how the compose file is made, this is basically having all of those services, and we are trying to link them all together so that you can so that they look and behave as if it's a single app. So if you have a monolithic app that you wanted to make it into multiple components, or you wanted to try it out using microservices, give us a call and we'll be able to help you with this. Thank you for the time and watching this.